What would be the best way to make a part for a firearm, and specifically a cylinder for a firearm? We're talking about a revolver here. Now, I did a video called Italy, Brunei, BBM. That's what Brunei from Italy means. BBM, Olympic 6. Not the electric 6. The Olympic 6 zinc alloy frame, 8-shot, single and double action blank firing revolvers. And I did a really simple math equation for it to show that what you do is you start off with the maximum diameter of the cartridge, whatever it is, and you do the math for a specific equation, which you have to sit there and figure out in order to make it. And it's kind of a pain in the ass, but I'll just quote it really quickly if I can see it. I'm looking at the first frame. You end up working it out, and it really is basically this. You take the bullet diameter and multiply it by 4, basically. But that's only for 22 caliber. Obviously, the cartridge can have a bigger or smaller rim, and this is with the minimum amount of space. And this is one of the many ways to figure out the minimum size, bare minimum size you'll end up with. But I failed to do the successive or unsuccessful approximation method that you're supposed to use when designing a firearm. Now, if anybody's curious about this, this is mostly a math thing that I did, but this one's going to be about a practical example of making a cylinder with a specific number of holes in it that are around the center. Now, this has more than the usage of making a firearm. This has to do with things like how tightly packed can you make objects in a space, whether it be square or round. In the case of the opening for a shotgun shell, the most efficient packing method is using lots and lots of tiny pellets. That's why birdshot can pack more mass in a smaller space more efficiently. And for the same reason, water molecules do a better job than big square or round balls of ice. You're packing these surfaces or the space more efficiently. That's why if you want to make a really heavy slug, you use a birdshot round cut off and mix the shot, whatever it is, with, let's say, crayons is actually considered almost perfect, and then pour it back in. It depends on what the metal does in reaction to it. Lead is actually much better at bonding with crayons. Pouring it back in, packing it tight, and then scraping off the excess wax, you'll make a slug that breaks up on impact but stays together. So your shotgun, instead of having a pattern foot wide, has a pattern this big no matter how far it hits, when it hits, if it hits. But anyway, this has got to do with something more basic here. So I did a revision of this in a comment section. Someone asked me, what's the best way to make a cylinder? Well, the way that it says in the books on paper for engineering, and this has nothing to do with making a cylinder for a gun. But first thing I have to say is, what you're supposed to start off with if you're testing the limits of something is you start off making an extremely simplified version of this. The fewest number of parts, and overbuild it to figure out what wear and tear will happen over multiple uses. But you also deliberately make something weaker than it needs to be to see if it'll blow up and where. You're not going to find out where a 50 Magnum, 50 caliber Magnum pistol will break if you design it really over design it. You won't know where it breaks because it won't show any signs of breakage. If you design it out of weaker and weaker material, you'll eventually get a break if you do exactly the same design and make the pieces the same way or equivalent. You'll find out where the weak spot is, and you can overbuild that spot and keep it from doing it until you get a randomization of where the damage would happen if you overpower it. And then you build it up by, there's a bunch of equations for it, stronger material that can handle it, and you build it at least 50% stronger than it needs to be, preferably double the strength. If you're building a gun like a shotgun is rated at 11,000 psi, but some pistols are rated at 100,000 psi, you're going to have to start off with a shotgun that can tolerate, I would recommend, at least 15,000 psi, and a pistol would need a ridiculously high pressure limit of 200,000 psi in that case. That doesn't mean that that's what you're going to end up with, but that may be your shooting point, or the point you shoot for. Forgive me, I screwed up my own joke. But you would start off with things like, and I'm going to say this, and I've been trying to find a copy of the video, a YouTuber, the Royal Nunsuch channel, the Royal Nunsuch show, showed him firing a shotgun shell once successfully from a piece of PVC tubing because PVC tubing of a particular value is actually capable of chambering the shell perfectly. Under those conditions, because the barrel is the same diameter throughout, there's almost no chance for a pressure spike. So what you're doing is you're just testing the upper limit for the plastic. And depending on how thick it is, you'll get, it'll explode or it'll work. It won't work reliably, but it'll show you where the failure happens, which happened to be, in his case, slightly back from the end of the shell or forward because the shell expanded. If you used a shell that was steel cased or brass, it didn't blow up at all. Anyway, I can't find the video because YouTube took him down because he was demonstrating, number one, that it's a bad idea to make a gun out of plastic, and number two, the only way you could do it is have a shell or cartridge that has an integral barrel, which do exist. But anyway, let's talk about the methodology for making the cylinder for a revolver. I will get to the angry or not so angry comments in a minute, but this is much more useful. Cut a piece of round bar stock 1/4 inch longer than the cartridges that you're going to use. This is the starting point, the blank. And 3 times the maximum diameter of the cartridge. 3.25 times. This is the way you're supposed to do it. Then at the center, you center punch an indent. You have to find the center of this cylindrical shaped piece of metal. This is the blank you start off with. Then you evenly space 6 more of them, or whatever the number is, halfway from the center to the edge. And yes, you have to look up the geometry problem that we all did with that little compass thingy to make circles. This is the easiest one because you use the diameter, a diameter, and then you create the other circle points. And this allows you to get away with making 6 evenly spaced points, exactly halfway from the center point out. It doesn't pay attention to the size of the cartridge. You can use a smaller cartridge or a larger one, but only up to a certain point, up to the point where they would touch. But anyway, you do the indents there. You'd use a small drill in the cylinder blank's center. Then make a jig to that to fit on for a hole for a drill press, and then line it up and then lock it. And then you would rotate the round metal bar stock and drill exactly the same way each time. No, they're not going to be perfectly straight up, but they'll all point the wrong way consistently. But you have to drill the center hole for it and then put the pin on it and make sure it's positioned the same way and then start drilling. You'd have to approach it that way. And that means that any inconsistency this way will be reproduced while it rotates. Now, if you're doing it ideally, you would move this thing around so that all the holes are parallel with each other, instead of rotating it on the center jig. The way you're supposed to do it, according to everywhere I looked up, is you're supposed to rotate it according to the jig so all the holes line up, supposedly, top dead center. This is where things get kind of confusing. Depending on the drill you're using, you're supposed to, of course, make a small drill a hole and then bigger and bigger and bigger for each cylinder. But you're supposed to do it by moving it rather than rotating it. I picked the one for rotating it, and the response in this may be wrong, because I found 2 different books on how to do this. One of them, obviously, with it rotating on a jig, makes it easier. But truth be told, they won't be parallel to each other. But anyway, after you do this, and you consistently drill it, one form of consistency or another, progressively using larger and larger bits to make a chamber, all of the chambers will line up the same way if in the same position, top dead center, rather than moving it around, making them all parallel. Now, this is a mistake on my part, and I'm having to do this video. You are truly better off making a jig that holds the lump of metal totally still without rotating it, without even putting a pinch hole in it. Just punch the dents in, and then drilling it consistently. Then the next part is you use the center hole. Obviously, in my opinion, my original instruction to the person of rotating the cylinder is a bad idea. You want them all to line up parallel. That's very important. Then you take the center hole you drilled that's supposed to be what it spins on, and you put it on a lathe or on a drill. I would recommend a lathe, but you can also do a jig in the drill itself, nut and bolt type will work. And then you slowly shave off the metal on the outside to get it to exactly perfectly straight up and down too, so everything is in parallel. That means that if you were to make a volley gun, for instance, this way, where you fire all 6 or even a 7th in the middle shot, they'll all hit in a pattern that's the same size as your cylinder, hypothetically. So I'm correcting instructions I left there. I'll also retype them today. And I'm also stating that this would be the methodology that would be considered preferable or ideal in books. And of course, I started off by saying you have to use mild steel, and then you have to this is first and foremost. Then you harden the metal either by heat treating it or whatever, or adding a layer of material on the outside to make it hardened. I think it's called case hardening. Now, and that might make it brittle. And this is on a video I talk about a blank firing gun and the legal methods you can use for using it as a starting point to end up with a pistol. You can technically get away with, this is not the way you're supposed to do it, altering a blank firing pistol to fire real rounds. And ironically, one of the types that's available that uses a shotgun primer has almost exactly the same chamber diameter, not the length, as the .22 Magnum. But the point here is that if you're going to do this, this is a lot of work. You're going to have to make a cylinder. Don't load a real bullet into a zinc body gun with a zinc cylinder. If you do this, you'd have to make a new cylinder, which means you're better off just copying the whole thing and really legitimately making a gun. But I also told the person in the comment section, if you're going to do this to test whether or not the material is good, you start off with a pistol that's just a single shot, and you deliberately test the hell out of the material. And yes, there are examples of guns being made out of very weak material like aluminum and even zinc and all sorts of, even copper, that fire a bullet perfectly fine. You just have to follow a set of rules. One of them is keep the body length at 6 inches and the height of the gun at 4, so it's not considered a extremely concealable weapon. Even though you're not required to do that, please keep it that size. That also makes things easier, number one. Number two, don't skip the level of rifling the barrel. That's why if you do a single shot, you're compelled to do that. Use electrochemical machining where you etch out rifling in it. The rifling needs to be there for legal reasons, but also so that it stabilizes the bullets. Next, if you're going to test these, you don't have to fire them this way to test them. Point the barrel and the whole gun straight down into the ground and make sure there's a hole in the ground so that whatever happens will go down into the ground and, in fact, put the entire weapon underneath the ground in a hole. Get a post hole digging tool and dig a hole 4 feet down and fire it that way. Don't even have to aim it. This makes it virtually impossible for you to hurt anybody. It will absorb some of the sound in a fully legal way, and it will keep you from becoming a statistic or a Darwin Award winner. Because if you build something like this, the likelihood of you eating the back of the gun is very high if you haven't gone ahead and deliberately tried to blow it up first. And the only way you can do that safely is to make sure that it's either going straight into the dirt or it's fighting gravity and comes straight back down. And again, also after that, put up something that stops it from hurting anybody. Even a piece of plywood at an angle, bouncing the pieces off would be good. Okay, that's the useful content for the day. Now we're going to get to the comments. Have you ever read the Constitution? You should read it. This person posted this under a video where I quoted it. Next one. Do you know who funds Fact Checker and who came up with it? I check the fact checkers. The fact checkers I list, I will double check. And again, this is about a specific video where I point out that a person claiming to be a whistleblower, when he actually talked to the authorities he's supposed to talk to, admitted that he didn't actually tell the truth. In public, you can get away with lying. There's no real consequences. But if you're put under oath by the Postmaster General, a real one, you have to tell the truth. And he knew that he was going to have to tell the truth. And he said that he had his statements written out by Project Veritas's, what was his name again? O'Keefe. And that's it. That's the end of it. Every single source we found for any kind of election tampering has turned out to be a lie or false or just wrong. Thanks for watching. Good day. Good luck with that.